Hi ma'am, my name is Ron Justin F. Bacolio and I'm from BizMath Ed 3A, and as of now I'm going to explain my midterm exam linear algebra solution and answer. Thank you ma'am, and now I'm going to start.
In item number 1, given the matrices below, compute the indicated expression it is defined. So we have a given matrices of A, B, C, D, and E. Now let's find A. So we have a given expression of 2 multiplied by transpose A plus C. So first we need to get the transpose of A. So just simply make your row into column. So we got the matrices like this. Then multiply by 2. Multiply all elements of the matrix into 2. Then we can come up with this answer. And now we can finally find what is 2 multiplied by transpose A plus C. So we add this into matrix C, then we can come up with the answer of 7, 2, 4, 3, 5, and 7. Next, let's find B. We have a given expression of transpose D subtracted by transpose E. So first, we need to find the transpose D. So we have a matrix here, D. Just simply make your row into column. As you can see, the row of the D become column. And now we have this answer, the matrix. And next we find transpose E. So just like D, we make our row into column. See that? Now we can simply find what is transpose D subtracted by transpose E. So just copy this transpose D, then subtract it by transpose E. This here. So we can come up with the result of matrix. Then the elements of -5, 0, -1, 4, -1, 1, -1, 1, -1, and 1. And now let's find C. So we have the transpose of D minus E. So first we need to find D minus E. So we have a matrix of D here and E. So just copy the matrix of D, then E, subtract by E. So we can come up with the result of this matrix, and having an element of -5, 4, -1, 0, -1, -1, -1, 1, and 1. Then we can easily find what is the transpose of D minus E. Just simply make the row into column. The row into column. And that is the result of this expression. And now let's find B. So we have here a transpose B plus 5 multiplied transpose C. So first we need to find transpose B. So we have a given matrix here of B. So just simply make our row into column. So we can get transpose B. The next, find transpose C. Again, just simply make your row into column here, so you can see. Then we can find transpose C. Then multiply transpose C into 5. So 5 multiplied by 1 equals 5. 5 times 3 equals 15. 5 times 4 equals 20, and so on and so forth. So we gather this matrix, and now we can easily find what is transpose B plus 5 multiplied by transpose C. Just copy this transpose B here, then add the 5 multiplied by transpose C here. But as you can see, the two matrix has different size. Here, as you can see, this is 2 by 2, this is 2 by 3. So we can add a matrix with different size, so we can come up with the result of undefined. Now in E, we have 1/2 multiplied by transpose C minus 1/4 multiplied by A. So first we need to find 1/2 multiplied by transpose C. So we have a matrix here of C. Just simply make your row into column here, then multiplied by 1/2, so we can come up with this result. Then let's find 1/4 multiplied by A. So we have a matrix of A here, so copy the matrix of A, then multiplied by 1/4, each element multiplied by 1/4, then we come up with the result of this matrix. Then we can finally find what is 1/2 multiplied by transpose C minus 1/4 multiplied by A. So just copy the 1/2 multiplied by transpose C, then subtract it by 1/4 multiplied by A here. So we can come to the result of a matrix of here, then the element of 1/4, 3/2, 9/4, 0, 3/4, and 9/4. Now in F, we have B minus transpose B. So we need to find the transpose B here, the matrix of B. So row, the column, row into column. So we can come up with this result of transpose B. So we can find now what is B minus transpose B. Just copy B here, the matrix of B, then subtract it by transpose B here. So the result is 0, -1, 1, 0. In G, we have 2 multiplied by transpose E minus 3 multiplied by transpose D. First, we need to find 2 multiplied by transpose E. We have a matrix of E here, so just find the transpose E. So just simply the row, so column, row into column, and row into column. Then multiplied by 2, the elements of transpose E, so we come up with this result. Then let's find 3 multiplied by transpose D. So we have the matrix of D here. So let's see first the transpose D. So simply row into column, then multiplied by 3, so we can come up with this result. Multiply the elements of the matrix into 3, so have the result. So now we can finally find what is 2 multiplied by transpose E minus 3 multiplied by transpose D. So just copy the result of 2 multiplied by transpose E, which is this. Then subtract it by the 3 multiplied by transpose D. So here is the result. Then we, after subtracting the matrix here, we can come up with the result of this matrix, which is the element of 9, 1, -1, -13, 2, -4, 0, 1, 6. And now in H, we have transpose of 2 multiplied by transpose E minus 3 multiplied by transpose D. As you can see, we already gathered the result of this in the previous letter. So we just copy it, then we just copy the result of it, then subtract it, then we can come up with the result of this, which element here are 9, 1, negative 1, negative 13, 2, negative 4, 0, 1, negative 6. Then we now can easily get the transpose of this given expression. So here are the transpose of the given expression: 9, negative 13, 0, 1, 2, 1, negative 1, negative 4, and negative 6. And now in I, we have C multiplied by D, then multiply it by E. Then we have a matrix here of D, C, and E. So first we need to find C multiplied by D. So just copy the matrix of C and D. To multiply the two matrix, we need to multiply the H element of the row into the H element of the column. So for example, 1 times 1 equals 1. 4 times negative 4, negative 1 is negative 4. Then 2 times 3 equals 6. Then add it all, then we can come up with the result of 3. And until we gather all the results, then we can come up with the matrix of the given multiplication. Next, we can easily find what is C times D, then multiply by E. Just copy the answer of C multiply D here, then multiply by, divide it by the matrix E. Again, multiply each row into column to get the result. So we have a result of 65, 26, 69, 185, 69, and 182. In item number 2, verify that the following matrices and scalars satisfy the stated properties on matrices. We have given matrices here of A, B, and C, and the scalars of A equals 4 and B equals negative 7. And now for A, we have A multiplied by B times C equals scalar A times B equals C equals B times A scalar times C. So first we need to get this. So B times C, we have a matrix of B which is 0, 2, 1, negative 4, and the matrix of C which is the element is 4, 1, negative 3, negative 2. To multiply the two matrix, we need to multiply the each element of row into column. So first 0 times 4 equals 0. So 2 times negative 3 equals negative 6. So 0 plus negative 6 equals negative 6. The next is 0 times 1 equals 0. Then 2 times negative 2 equals 4. So we come up with this answer, negative 4. So next is 1 times 4 is 4. Then negative 4 equals times negative 3 equals positive 12. Then 4 plus 12 equals 16. So next is 1 times 1 equals 1. Then negative 4 times negative 2 equals 8. So it equals 8. So 8 plus 1 equals 9. So we come up with this answer. Then we can now find the scalar A times B C. So the scalar A is equals to 4. So just multiply the scalar into each element of the result of BC. So we come up with this answer of negative 24, negative 16, 64, and 36. Now let's find the second equation, which is scalar A times B times C. So to find this, we need to multiply the B first into scalar A, which is 4. So we count its result. Then multiply the result of AB into matrix C. So we come up with the result of negative 24, negative 16, 64, 36. To get this, as I said, that we need to multiply the row into column to get the result. And last equation is this B times scalar A times C. So first we need to find this. So the scalar of A is 4, so 4 times the matrix of C, which is 4, 1, negative 3, and negative 2. So we come up with this result. The next is we find the B times this, so the result of this, then the matrix of B. So here, as I said again, that to get the multiplication of the two matrix, we need to multiply the each element of row into column. So we get the answer of 24, 16, 64, and 36. Since A B C equals AB times C equals B times AC, therefore it's satisfied to the stated property on the matrices. And now in B, so we have this A times B minus C equals A times B minus A times C. So first we need to get this. So we need to find first the B minus C, which is the matrix of B is this, then the matrix of C is this. So we need to subtract these two matrices and we come up with the answer of negative 4, 1, 4, and negative 2. So next is we can find the A times B minus C. So copy the answer of B minus C, which is this, then multiply it by matrix A, which is this. So to multiply the two matrix, we need to multiply the each element of row into column of the second matrix until we come up with this answer, negative 16, 5, 8, and negative 6. So next we need to get this equation. So AB minus AC. So first we need to get the AB. So the matrix of A is this, then multiply the matrix of B, which is this. So we need to multiply the each row into column, each row into column, each row into column, and each into column. So we get the answer of negative 1, 10, 4, and negative 12. So next is we need to find AC here. So we all know the matrix of A is this, then the matrix of C is this. So we come up with the answer of 15, 5, negative 4, and negative 6, just multiplying this. So now we can finally get the answer of AB minus AC. So copy the answer of AB, which is here, negative 1, 10, 4, and negative 12. Then copy the answer of AC, which is negative, which is 15, 5 before the and negative 6. So we need to subtract the two matrix and we come up with the answer of negative 16, 5, 8, negative 16. Since A times B minus C equals A times B equals AC, therefore it is satisfied the stated property on matrices. In C, we have B plus C times A equals BA plus A. So first we need to get this. So let's find B plus C first. So we have a matrix of B here. So this is 0, 2, 1, negative 4. Then add the matrix of C, which is this 4, 1, negative 3, and negative 2. So by adding this, the elements of the two matrix, we come up with this answer 4, 3, negative 2, and negative 6. So next, we can finally get what is B plus C times A. So copy the answer of B plus C. So here, then multiplied by A, the matrix of A, which is 3, negative 1, and 2, and 4. So we so multiply the each element of row into column to get the each element of this matrix here. Multiply the row, then add to find the 18. Again, 4 times negative 1, then 3 plus 4, add the 2, then we can get the answer of 8, and so on and so forth in this situation. Then next is let's find B times A plus C times A. So first we need to get what is B times A. So let's back what is the matrix of B, which is 0 to 1, negative 4 then times it with the matrix A, which is 3, negative 1, 2, and 4. So again, multiply this row into column here, then add the answer of 2, so we can get the answer of 4, and then again multiply it again here, so we can get the answer of 8, and so on and so forth. So we have the answer of 4, 8, and negative 5, and negative 17. So next, let's find what is CA. So CA, we have a matrix here of C, which is this, then A, which is this. So multiply the two matrix again, the row into column, so we can get the answer of 14, 0, negative 13, and negative 5. Next, we can easily find what is BA plus CA. So let's just add these two matrix, so we can get the answer of 18, 8, negative 18, and negative 22. Since B plus C times A equals B times A plus CA, therefore matrices and scalars satisfied on the stated property and matrices. Now in D, we have here the scalar of A multiplied by scalar of B times the matrix of C equals the scalars of A multiplied by scalars of B multiplied by matrix of C. So first we need to get this equation. So let's find first the scalar of B multiplied by matrix of C, which is this. So we have a scalar of B, which is negative 7 multiplied by the matrix of C, which is 4, 1, negative 3, and negative 2. So just multiply each element by negative 7, which is, we can come up with this answer, negative 28, 7, negative 7, 21, and 4, 14. The next, we can now finally find what is A times BC. So we have scalar of A equals to 4. So 4 multiplied by the answer of BC here. So multiply each element by 4, then we can come up with the answer of negative 112, minus 28, 21, and 14. Now let's find this. To find this equation, let's find this first. Let's find AB, which is the scalar of A and B. Then we know that the scalar of A is 4, then the scalar of B is negative 7, so we can come up with the answer of 28. Just multiply these two. Then we can finally find what is AB times C. So copy the answer of AB here, which is 28, then multiply the matrix of C, which is 4, 1, negative 3, and negative 2. So multiply the each element of the matrix C into 28. So we can come up with the answer of negative 12, negative 28, 84, and 56. So since scalar A multiplied by scalar B multiplied by matrix C is equals to scalar A multiplied by scalar B multiplied by matrix C, therefore matrices and scalars satisfy the stated property and matrices. And now in E, we have here E transpose of A plus B equals to transpose of A plus transpose of B. So first we need to get this. So we have to find first the A plus B. So we have a matrix of A here, which is this 3, negative 1, 2, and 4. Then add the matrix B, which is 0, 2, 1, and negative 4. So we can come up with the answer of 3, 1, and 3, 0. Then let's transpose this matrix. So we have this answer 3, 3, 1, 0. So we have the answer of transpose of A plus B. So next, let's find this. First, we need to find what is transpose A. So this is the transpose of A. So 3, 2, negative 1, and 4. Then find what is the transpose of B, which is 0, 1, 2, and negative 4. Then let's add the two matrices, so we can get the answer of transpose A plus transpose B, which is 3, 3, 1, 0. Since transpose A plus B equals transpose A plus transpose B, therefore matrices and scalars satisfied on the stated property of the matrices. And now for F, we have theory transpose of AC equals to A multiplied by transpose of C. So first we need to get this. So we have to find what is the scalar A times the matrix of C. So we have the scalar of A, which is 4, then multiplied by the matrix of C, which is 4, 1, negative 3, and negative 2. So we can come up with the answer of this, 16, 4, negative 12, and negative 8. So transpose this matrix, so we got 16, negative 12, 4, and negative 8. So we have the answer of this. So next we have to find this. So we just simply multiply the scalar A, which is 4, to the matrix of C, which is 4, negative 3, 1, and negative 2, the transpose of the matrix C. So we can come up with the answer of 16, negative 12, 4, 8. Since transpose A, C equals 8 times transpose of C, therefore the matrices and scalars are satisfied to the stated property of matrices.